Okay, we're going to work on what we call combined variations today, which is just going to be kind of a combination of what we did yesterday, and it's a little bit more complicated, but just in general, I just wrote this at the top just so you guys could remember the two relationships we talked about yesterday. So a direct relationship is going to be a variable times your constant of variation. So like y equals kx. And then just to the side there, if we need to find the k value, it should just be whatever the y value is divided by the x value, or whatever variables are in those same positions when we set these up. I don't know what is going on with my thing. Okay, now the inverse, if you're doing inverse, it's going to be division between the constant of variation and your variable. So that's y equals k over x. Just remember, k will just be a number. And in that case, if you don't know your constant of variation, to find it, we're going to multiply x and y there. So those are just kind of transforming those equations. Now, what we're going to work on today are called combined variations, but it's basically what it is. It's more than one variation within the same equation. So like we'll have, y varies directly with this and inversely with that, or something like that within the same problem. So we're going to practice setting those up today. And the one new term I'm going to add in today is that fourth little definition there, which is called a joint variation. Now, in that, a joint variation, in the description, if you have a sentence about this, it'll say varies jointly. A joint relationship is actually just direct. It's just going to be multiplication, but it's not just k times one variable. It'll be k times two or more variables. So varies jointly works like a direct, where you're going to multiply by your constant of variation, but it's going to have two, or it could have more variables. It just depends on what they give you in the problem. So we're going to work on setting these up today here in a second. So my first example, sorry, that's shaking. All I'm going to do underneath here, we're just going to translate these. The one thing, and it says this in the directions, you are not going to be given any numbers in this particular example. You have to put in a k to represent the constant of variation. So you can't forget to do that. That's the most common thing people will forget to do on any of these questions, is they forget to put in k, and then you can't find that relationship with that constant of variation is. All right, so all we're going to do, I'll slide this up just a little bit. In this first example, we're just going to take what's written and we're going to write it as an equation. So I'm just going to translate this. So if you guys remember from yesterday, if you see the word varies, that kind of translates in an equation to an equal sign. Now, what I'm going to do here, this says y varies, so I'm literally just going to say y equals. Direct is a multiplication with k, so I'm just going to do k, and then it says directly with the square of x. How would you write the square of x in an equation? X squared, exactly. X squared, that's literally it. It's just a little alteration from yesterday that's super similar. We did y equals k times x. This is considered a combined variation because it's an alteration of what we did yesterday. So just k times x squared there. All right, now the next one says y varies. So I'm going to write y equals. Now inversely is going to immediately imply to me I'm going to have k over whatever is going to follow this. So I'm going to put a k on the top. An inverse relationship is going to have a fraction. And then whatever it tells you underneath, or after that, is going to be underneath the k. So it varies inversely with the cube of x. So all you got to do, cube of x would just be x to the third power. That's all you would have to do to write that. We're not transforming anything or finding any k values. We're just rewriting these as an equation. All right, now this is new today. So jointly, if you see that, this says z varies jointly. So z varies is just going to be z equals. Jointly means whatever follows that, we're going to multiply those variables together. I just can't forget to put in the k. So just right after this, I'm going to immediately put k. And then jointly means whatever follows, jointly is a direct relationship. It's all just going to be multiplied. So this would be k times x times y. Technically, it doesn't matter the order you put those in, but usually we put them in alphabetical order if we have them in the same term. All right, and then the last one is the most complicated of all. So it says z varies, so z equals jointly. I'm going to read this whole thing. Jointly with x and y, so that's going to be a multiplication, like right here, x and y, that's going to be a multiplication relationship, and inversely with w. Okay, so if you have an inversely and a jointly or directly in the same problem, you want to put the k on the top of the fraction here. All right, so jointly, I'm just going to put a k, x and y, so super similar to what we just did. Then it says and inversely, so I'm just going to turn it into a fraction. Inversely with w would just put, excuse me, the w variable underneath that. So if you've got a direct and an inverse within the same problem, you're going to have the constant of variation will be in the top. Is anybody having a question? Okay, now I'm going to reverse this. I'm going to give you an equation, and we're going to write it out kind of backwards from what we just did. Okay, before I start, these are all legitimate formulas. So this is just mass of moving object related to the kinetic energy. So mass is the m, kinetic energy is n, velocity is v, and this is a true formula if you guys have seen this in physics maybe. Can anybody tell me the k value? Just looking at that equation. I have m equals 2n over v squared. What's the k value? It's 2, it's the number. Now, you will not see that in the description. Notice the questions we just did. I never said anything about a number, so that's why I had to remember to put k in. This is not part of the description. So when you do the description, and you don't have to write out like mass and kinetic energy, I'm not asking you to do that. Let's just do the letters. I'm going to say m varies. Okay, now this has got two things going on. So I have 2 times n, so my constant of variation multiplied by m. So I'm going to say directly with n, because it's multiplied by my constant of variation there, it gets on the top. And then, and I'm going to write inversely with, and you don't have to write out like the square of v or something like that. You could just put with v squared. You can just do it like that. So it's directly with n, because that's in the top, being multiplied by my k value, and inversely with any variables that are in the bottom. Okay. Now, super tricky. Somebody raise your hand and tell me, what do you think the k value, this is the volume of a sphere, 4/3 pi r cubed. What do you think the k value is for that formula? What's the constant of variation? It is not 4/3. You're close. 4/3 is part of it. Yeah. So pi is not a variable, right? So the constant of every time you would find the volume of a sphere, right? You would use 4/3 pi. The thing that changes is the radius every time. But that 4/3 pi would be a constant. That would always be part of the formula. Pi is a number, not a variable. So when I describe this, everything's being multiplied here, right? And I'm not trying to be misleading because there's a fraction in there, but there's no variable in a denominator anywhere in that problem. So this would just be like volume. So I'm just going to say v varies. 4/3 times pi, that would be your k value. You're just multiplying that by the radius cubed there. So this would be directly. And again, you don't have to write out radius or anything like that. Just, I'm going to say directly with r cubed, or r to the third. That's all you have to do. But the k information is not involved in the description. So the 4/3 and the pi, they don't appear. They'd be constant. Every time you find the volume of a sphere, you'd always use that. So it's not part of the description. All right, now the last one I think is very tricky for finding, well, I thought that one was too, but the last one is area of a triangle, base times height divided by 2. Anybody know what the k value is for that one? It's not 2. What's another way you can find the area of a triangle? Maybe a different way you learned how to do it. 1/2, right? This is the same thing as, this is how I learned it. I never learned base, I mean, they're the same, but 1/2 base times height would be the exact same formula. That's how I learned it, not base times height divided by 2, but they both are the exact same. So the k value there is actually the 1/2. Now, everything's being multiplied there. I have no variable in a denominator, so I don't have any kind of inverse relationship. If you have 2 or more variables that are multiplied together, so we have the base and the height here, that's what we call a joint relationship, because we're gonna multiply more than one variable by the k value to do that. So this would be area. I'm just gonna write A, varies. And then we would just say jointly. That is a direct relationship, but jointly just means I've got two or more variables that I'm multiplying together. So jointly with B for base and H for height. That's all you have to do. Yeah.
So if there's any variables on top of that too, K would be one.
Say that one more time.
If there's any variables on top of that,
Depends on the question. It could be, yes. Could be. I don't know if I have any on here where, we'll have to look. I don't know. We're just going to go through a couple more examples. Okay, now, this guy is like what we did yesterday. This is like a double part question. So I'm going to write this real quick. This says y varies. So y equals, don't forget, I'm just immediately going to write a k after this so I don't forget. Okay, jointly is a direct relationship. Jointly just means you're going to multiply whatever variables follow. So varies jointly with x and z. So I'm just going to write it like that. Then it is going to give you just enough information to figure out what that k value is. So here would be a general form for that. It says if y is 5, so I'm just going to substitute each one of these in. K will be the only thing I don't know because it's not part of the description, so we have to figure it out. X is 3 and z is, I don't know why I just wrote z, z is 4. So it says y varies jointly with x and z. If y is 5 when x is 3 and z is 4, we're going to find the k value here. So this would just be 5 equals k times 12. So to get that alone, it's not the greatest number in the world here, but it would be the k value is 5 over 12. So then the actual equation that we would use here would be y equals 5/12 xz, just like that. That would be a general equation we could use for any situation here. And then these guys always have like a secondary question. So this says, like second part of the question, I'm going to use this equation we just wrote though. Find y when x is 6 and z is 8. We're just going to plug numbers in, right? So find y, so I don't know y. My constant of variation, we just solved for that. That was 5 over 12. And then x is 6 and z is 8. So I'm literally just plugging this into my calculator to figure out what my y value is going to be here. So I'm going to do 5 over 12, whoops, and then times 6 times 8. And it might be a nice number, it might not. In this case it is, so y is 20. That would be my answer for the second part of that question. Is anybody having a question? Okay, we're just going to try a couple more and then I'm going to have you guys do some word problems with these. All right, so this guy says y varies. So I'm going to write y equals. Okay, now I would just encourage you, just immediately after you write the equal sign, just put a k after that, so that way we don't forget. Okay, now this says directly with x squared, so it's just going to be k times the x squared, and inversely is going to dump whatever follows that into the bottom of a fraction. So inversely, so I'm going to turn into a fraction with z. So there would be my general form for that. Then they're going to give you just enough information to figure out that k value. So it's going to say if y is 12, so I'm going to sub 12 in for y, k is what we're going to solve for. We don't know that. X is 2. Now, in this question, the x is squared, so don't forget to perform that operation when you plug that variable in. So I'm going to plug in 2 for x. I'm going to have to square the 2. And then inversely with z, so the 7 would be on the bottom. All right, now, you could simplify this however you want. The top of that would end up being 4k and then over 7. There's a couple different ways. I could just multiply by the reciprocal here real quick, or if you want, I'm just going to take, I'll just do it right on my calculator screen. I'm going to take 12, I'm going to multiply it by 7 to get that out of the denominator, and then that would be equal to 4k, so then I'll just divide that by 4. So ultimately, if I solve that, my k value is going to end up being 21. All right, so once you have that, I'm just going to come right back over here and just write the general form for this. So it would be y equals 21x squared over z. That would be a general formula I could use for any situation, which I'm going to use as the secondary part of that question. Sorry, this is really close to the edge of the paper. It says find y, so we're going to find y here, when x is 3 and z is 9. We're just plugging numbers back in, but we got the 21 in place for the k. We have to find that first. So to answer this part, we don't know y. I know k is 21. For this example, it says x is supposed to be 3. Don't forget, in that original problem, it's x squared, so you got to square the 3. And then over inversely, so we're going to put this in the bottom, this will be 9. So however you want to do it, I'm going to do 21 times 3 squared would be 9, right? Oh, and then we're going to divide by 9. So those 9s actually will cancel out there. And y is going to end up being 21. Is anybody having a question how I'm finding k, writing the equation, any of this? It's a lot in one problem. Okay, I'm going to try one more with you. So this says y varies. I'm going to write y equals, and I'm just immediately going to put a k, because they're not going to give me a k in the description, but I have to find what the constant of variation is for this relationship. Jointly means you are going to multiply together whatever information follows that. So jointly with, let's see, we got cube root of x and z squared. So that z squared is not under the cube root, it's just to the side. So I'm just going to kind of plug that in. All right, now they're going to give us just enough information to figure out the k value. It says y is 64. We don't know k, that's what we're going to solve for. We're going to do cube root of the x value, so that'd be cube root of 8. And then we're going to do the z value, which they're giving us as 4. We're going to square that. All right, so anybody remember cube root of 8? 2. And what would 4 squared be? 16. All right, so I got 64 equals 2 times 16 is 32, right? So what's my k value? 2. All right, so just a general equation here that we could write once we know the k value would be 2 cube root of x z squared, all just multiplied together. Now here's my secondary question over here to the side. They always ask, kind of like an application of what you just did. It says find y when x is 27 and z is 2. So we're just going to plug stuff in. Don't know why. I do know the k is 2. We're going to do cube root of 27. And z we're supposed to square, so it'd be 2 squared. All right, so anybody remember cube root of 27? 3. And then 2 squared is going to be 4. So this would be 2 times 3, which is 6, times 4. So the second answer to that question is going to be 24. I'm sorry, I'm really slow on the screen here. Does anybody have a question? These are not terrible. It's just tricky to set them up. Okay, now, do not be intimidated by the word problem. You're just going to pick information out here. Okay, so this says, and you can use whatever variables you want, but I'm going to use kind of what's in the problem. So this says the cost, so I'm just going to use C for this, of material used in making a Frisbee varies directly. So I know I'm going to do some multiplication here with the square of its diameter. So I'm just going to use D for diameter, all right? So C varies, C equals, direct relationship is going to be multiplication, but I would just tell you, immediately after you write the equal sign, just put a K after it, because you're going to have to figure that out. So varies directly with the square of the denominator. How would I write the square of the denominator? The diameter, I can't speak. How would I write the square of the diameter? D squared, right? So don't forget the squared on that because that would mess up our answer. Okay, so here's my general form. Okay, it costs the manufacturer, so that's giving you the cost, that's the C value, 45 cents for the material of a Frisbee that has a 9-inch diameter. All right, so we're going to use this to find K. So a 9-inch diameter, but the diameter ends up getting squared for this question. We're going to use this to find K. So I'd have 0.45 equals K 9 squared is just 81. Okay, this is going to be a super small number because, right, I'm going to end up dividing 0.45. I'm going to divide that by 81 to get the k by itself. Okay, if you guys have this lovely calculator, you can hit math, enter, and just convert that to a fraction real quick. If you guys have a scientific calculator, you can do that on there too, and I will be happy to show you. On this particular one, because you're dealing with a decimal, I would do like 0.45 divide by 81, and then there's a key that'll convert it to a decimal, and it's like second, and then you'll see F and with a little arrow D, and I will be happy to show you where that's at. But I want to go ahead and use the fraction here. It'll make the problem a little easier to do. So this 1 over 180 would be my k value. Now that doesn't turn it into an inverse relationship. We're not going to have a variable in the denominator. So this would be cost equals 1 over 180 multiplied by the diameter. I keep saying denominator. Diameter squared. Now I'm going to show you this real quick. You can leave it like that. If you would rather, if I actually thought about that diameter squared being over 1, the cost here is going to be, if I do I'm just going to simplify this fraction. If I do 1 times the diameter squared, that would be on the top, and the 180 would be on the bottom. It's still a direct relationship, just might be easier to plug it in that way, and then you don't have to deal with the fraction. So it says, what is the cost? So here's our secondary question. What is the cost? We don't know the cost for a Frisbee with a 12-inch diameter. So the diameter squared would go on the top, and the 180 would go on the bottom to figure out the cost here. All right, or you could do 1 over 180 times 12 squared. Either way, we're going to do 144 divided by 180 to get this answer. So the cost here then would be 80 cents for every Frisbee we make. Is anybody having a question? Okay, this one's kind of weird, but I'm going to do one more. It says the number of bags of grass seed. So number of bags, I'm just going to use N. Needed to reseed a yard varies directly with the area to be seeded. So I'm going to use A for area. And inversely, so we've got another, and inversely with the weight of the bag of seed, and I'll just use W for the weight. All right, so number of bags, and then I'm just going to immediately, after I put my equal sign, put a K value so I don't forget to solve for it. So it varies directly, so we're just going to multiply K times this, the area to be seeded, and inversely, which is going to turn that then into a fraction, with the weight of the bag. So I'm just going to put a W on the bottom. Okay, now, here, this is a little bit weird. It says it takes 2 3-pound bags. So the number of bags would be 2. The weight of the bags, it says it takes 2 3-pound bags. So the weight is supposed to be 3 pounds there. And we're going to seed an area of 3,600 square feet. We don't have to do any conversion or anything like that there, but we're going to use that information to figure out our K value. All right, so, I wrote too big here. So let's do, we'd have 2 equals K times our area is 3,600 divided by the weight of the bag, which is 3 pounds. What I would do real quick, I'm just going to multiply both sides by 3 to get that out of the denominator. So I would end up with 6 equals K times 3,600. So the K value here is going to be 6 over 3,600, which that's a lot, or a really tiny decimal. And it's 1 over 600. All right, sorry, I'm too close to the bottom of the page here. So my general formula, this is kind of weird. So the K value would be 1 over 600 times the area divided by the weight of the bag. Okay, now, an easier way to write this, if I have this fraction on the top, could just be the area over 600. What's going to happen here algebraically? That 600 is just going to go into the denominator. So it's just going to be your area over 600 times the weight. That would simplify to be that. If you're like, what the heck, where did you get that? The top of this would be A over 600 divided by the weight. You could do your keep, change, flip. But anytime you have a fraction and you divide by something like that, those two things just get multiplied together to simplify that. I'm just not having a lot of space here to write all that algebra out, but that's what's going to happen. Now, once you have this, it says it takes 2 3-pound bags to seed this. How many 3-pound bags for 9,000 square feet? So we'd plug in the 9,000 for A. The weight of the bag is staying the same. So the weight of the bag, it still says a 3-pound bag. So to answer the second part of that question, we're just going to take 9,000 divided by, I'm going to do 600 times, I'm going to put this in parentheses because I need to figure out what the bottom of that fraction is. So 9,000 divided by, and then I'm going to put 600 times 3, or that should be 1,800 if you want to figure out what that is first. But this would be 5, and that's just the number of bags that we would need. Is anybody having a question?